Hello everyone, Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ayman Yunus and I am here today to present to you a series of with utilities construction. With utilities are many, such as foul sewer network, surface and groundwater network, potable water network, and TSE network. And we'll start today with a very short session, and we'll give you a brief an introduction about the foul sewer network construction. I'm sure that the series that I'm going to introduce to you is going to add value for your knowledge and your information. And please like this video and subscribe for my channel so you can get notified with all new videos that will be coming in our channel in the coming few days. And we'll start today, as I said before, with the construction of foul sewer network. And we'll give you today a small introduction in this session about the foul sewer system mechanism and the house connection shop drawing. How can we prepare the shop drawing, and what are the things that we need to produce or review any shop drawing. As we can see here, this is the plots. Some developed plot and some plots are not are undeveloped. Developed plots means these plots has a building, constructed building, and this building has its internal drainage system, and this internal drainage system consists of inspection chambers, and these inspection chambers will throw that flow to a septic tank. What is septic tank? Septic tank is a huge chamber, and this chamber will be used as a temporary system inside each plot, and the government will assign some tankers to come from time to time to take the water or wastewater from this septic tank and throw it to the live network. Our job in these sessions will teach you how we are going to terminate the temporary system inside the developed plots and take the flow into the main network system, and this network system will go to finally to a pumping station, and through a rising main it will go to sewage treatment plant, and through TSE pressurized lines it will be used for irrigations work. Something very important for any contractor who is going to produce shop drawing, the contractor shall verify the plots with the latest MMUP policy plan to ensure that all plots have a lateral connection. Also, we need to make sure that the angle between the lateral connection and the main line in the direction of the flow is 90 degree or more. Why 90 degree or more? To make sure that the flow going from the lateral connection to the main line is in the same direction of the flow, so we can avoid any disturbance that may happen to the flow, which may cause a reduction for the velocity or the design velocity. And therefore this step is very important as well. And finally, we have to mention that the foul sewer pipelines are gravity pipelines. And we'll go now to know how to check the shop drawing, and this is a sample for the shop drawing, submitted shop drawing for developed plot. Developed plot, as I mentioned before, means has its internal drainage. Undeveloped plots had no constructed building or internal drainage, and in that case we will take the lateral connection from the proposed driveway, which is shown in the latest MMUP policy plan. What are we going to check here or to see here when we are preparing or checking this shop drawing? First, we need to see the internal drainage survey. The contractor will go to each plot, has its internal drainage network, and he will do a survey or conduct a survey for each inspection chamber. He will know what are the levels inside each inspection chamber and how the flow is going, so he can determine the final location of the manhole. Is this location of the manhole is final location as per the IFC drawing? No. The final location of this manhole will be determined based on the direction of the lateral connection to this manhole. For example, as per the shop drawing, this manhole could come little more or little back from the one which is originally shown in the IFC drawing, and therefore we have to check also the exact location and level of the manhole at the main line based on the lateral connection which we are going to construct. We need to make sure that the slope is going between 160 minimum or 110 maximum slope from the existing inspection chamber or existing manhole, which we call it MH1, inside the plot to the main sewer manhole. We need to check the separation between our house connection, lateral connection, and the other existing utilities, as we know quite well that the manholes are will be situated in the carriageway, and the inspection chamber is inside the boundary, and there are lots of longitudinal existing utilities in this way to the plot boundary, from the manhole to the plot boundary, and we have to fulfill all the requirement of the different authorities in the issue of the separation between the utilities. For example, we have to maintain 0.5 meter below the LV cable. We have to maintain 1 meter below the EHV cable, and we will go through these details as I mentioned before in the coming few sessions. And we need to check the soil cover above all the utilities at the cross section. We need 1.2 meter above the house connection in the carriageway, and inside the plot we need 0.6 meter. If the cover is less than 1.2 meter in the carriageway, we need to provide concrete protection. We need to check the house connection type. What does it mean, house connection type? We'll go to this in the coming flow slides in detail. We need to know the MH1 coordinates and level. As I said before, this inspection chamber or MH or manhole inside the house, which we are going to take the flow from it to the main line, we call this MH1. How do we check the slope? The slope will be 1 to the invert level inside the inspection chamber minus the level in the main sewer manhole divided by the length. This will give you the slope of our pipe. For example, here the slope is 1 to 13. 1 to 13 is in between 1 to 10 to 1 to 60, so this is an acceptable slope, and we can approve this shop drawing. One last thing I'd like to add in this sample, that the connection goes to the manhole, which could be a direct connection and or ramp connection or vertical connection. We call it vertical backdrop or ramp backdrop or direct connection. And in the coming sessions, we'll go in details on how these connections are being constructed, and what are the standard drawing for this one, and what are the minimum requirement for each connection. This is the house connection type. Here we said that we need to check house connection type, and I told you that in coming few slides we'll know what is the house connection type. Here as we can see, we have house connection type A, type B, type C, type D. What does it mean, type A, type B, type C, type D? Type A, as we can see here, that the inspection chamber is beside the septic tank. But type B, the house connection that we are going to, the inspection chamber that we are going to take the flow from it, is behind the septic tank. What is the difference between this case and this case? Means, why did they call this type A and type B? In both cases, the inspection chamber is very nearby the septic tank. But here, we can take the flow from the existing inspection chamber into our main network and make the overpumping for the live sewer network inside the plot from this inspection chamber to the temporary septic tank. But in this case, the septic tank is in our way to the connection. So we have to demolish the septic tank at the beginning as per this cross section and as mentioned in the specification. Then we will do the overpumping from this inspection chamber into our main network until we finalize our work in this area. What is type C? Type C means we have a lot of connections going to the septic tank, and these connections will not be going to one point. It means in this case, we have all the flow is coming to the septic tank from one point. All the flow here is coming to the septic tank in one point. But here, this inspection chamber and this inspection chamber and this inspection chamber throw this flow to different points inside the septic tank. And in this case, when we are going to construct here MH1 and demolish the existing septic tank inside the plot, and we have to make sure that the level of the manhole follow the lowest level of the connections that are coming to the septic tank. Means we have an invert level for this pipe at this point, we have invert level for this pipe at this point, we have invert level for this pipe at this point. So we have to follow the lowest level of these three when we construct our MH1. The last one is the type D connection. Type D connection is mainly for the future house connection or for undeveloped plots where there is no internal drainage system. And in this case, we will only take that lateral connection or house connection to the plot boundary as it is shown here. And the depth of the our connection will depend mainly on the plot area. Plot area, if it's 2,500 square meter or below, we will use 1.2 meter depth of our connection. But if it's more than 2,500 square meter, we will use 2 meter depth for our pipe connection. Here, as we can see, these are the inspection chambers that we are going to construct inside the house, or as I said before, any the manhole which you are going to use inside the building. This is called MH1. The last manhole which we take the flow from it inside the existing building to our manhole, this is called MH1, which is shown here in this drawing, for example. This is called MH1. This we call it MH1. MH1 could be inspection chamber or could be manhole. When will we use inspection chamber? When will we use a manhole? We will use inspection chamber if the depth is up to 1.5 meter. We can use inspection chamber, and these inspection chambers are divided as per the standard drawing into two categories. The first category is type A and the second category is type B. Type A and type B depends mainly on the number of the branch connections that are coming to be connected to the this inspection chamber or MH1. As we can see here, this is the finishing as per the standard. These are the cross sections of the inspection chamber. Will be constructed from SRC concrete, SRC 40 for the walls and SRC 40 for the base as well, and benching will be SRC 20, and the slope of the to the benching inside the plot inside the manhole will be 1 to 10. What does it mean, benching? Benching means the shape of the channels inside the manhole that will take the flow through it, and we'll go in details about this issue in the future, but let's just now I'm giving you a brief or some idea about the system itself. Okay, now we have something else called chamber type C. What is type C? Type C, in case of we have some chambers we need to construct inside the building due to its deficiency or its level is not compatible with our MH1 and our main network, we need at that time to adjust this inspection chamber. This inspection chamber will be constructed as per mentioned in type C detail, which is this one. It will be constructed from bricks only, and the slope will be 1 to 10 as well. And this will be this has to be instructed by the engineer. The base of this one will be mass concrete SRC 20. And we'll go now to the MH1. What is MH1? MH1 is the manhole that we are going to construct in case the depth is more than 1.5 meter up to 2.5 meter maximum, and These are the details of this one. As we can see here, the concrete wall and the concrete base are SRC 40, and the benching as well here is SRC 40, and the slope is 1 to 12. There is also cover slab, and there are seating rings, there are DI cover and frame. Unlike the inspection chamber, which was very simple, as we saw in the previous slide. See here, only there is a benching with SRC 20 into the ground level. But here we have seating rings, and we have the paving and all for road surfacing and these things. Anyway, we'll go in detail about these issues in the future, and we'll see it one by one, so you can get I'll give you the closer idea about each and everything single item that I mentioned in this session. Now we'll go to the house connection shop drawing for undeveloped plot. For the undeveloped plot, as I mentioned before, there is no internal drainage system, there is no existing building, so we need to first verify the area, which is this example, it's 1210 square meter, and this is less than 2500 square meter. As we mentioned before, if it's less than 2500 square meter, means our connection will be at 1.2 meter from the ground level or finish road level at this area, at the plot boundary location. And we need to check the driveway location, because we will take our connection from the driveway location to the manhole. We need to verify the exact location and level of the manhole at the main line based on the direction of the flow. We need to verify the slope, which we have that it's between 1 to 60 and 1 to 10. As we calculated it here, it's 1 to 16, which comes between 10 and 60, and this is acceptable ship drawing for us. We need to check the separation with the existing utilities, the soil cover above all the utilities. We need to check the house connection type, which will definitely be type D, as we saw in the previous slide here. It's type D. See here, connection to property with no existing internal drainage, type D, and this is what I said regarding the plot area. It's less than 2500 square meters, so that connection should come at 1.2 meter. And the end cap details. What is the end cap? What is the end cap details? From where we get this one? Where is this? Is there any standard for this end cap details? Yes, there is a standard for this one. This is the Ashghal standard drawing. This shows the diameter of the pipe, invert level of the pipe, northing and easting of the pipe at the plot boundary location. And by this we reach to the latest part in our session, which will explain the tools required to review any shop drawing. We need to know the PWA standard drawing, we need to know Kahrama standard drawing, we need to read the issued for construction drawing, general notes, and we have to read it very carefully, and the typical details as well. We have to have some knowledge about the QCS latest Kahrama specification, and we need to have a well understanding of the submitted shop drawing purpose. Since this shop drawing will be used by everyone, all parties will use this shop drawing, and this document will be the document that we are using to construct anything in our site, and any mistake on this shop drawing could lead to huge problems in the site during construction. And therefore we need to make sure that this drawing is readable for each one. For example, here I can see the coordinates of the connection. We can see the coordinates of the connection, we can see the manhole coordinates, we can see the flow direction, we can see the slope of our pipe, so we can know the level of the pipe at any point in this section. And by this we have arrived to the end of our session today. Thank you very much indeed for your listening, and thank you and bye.